Hey everybody, today I'm doing another math problem, and today basically we're doing something very basic. We do an introduction to fraction, and so basically in this video I will try my best to explain the basic concept of fractions by doing something that is, visible, um, like this little diagram that I have, and also uh, a very brief definition. For example, you can say, what is a fraction? Okay. So basically, a fraction is a number that represent part of something. Part of a whole. That's a fraction. In order to be a fraction, it has to be part of the whole. In other words, like $1. If you have $1, that is not a fraction, that is a whole number. But if you have 50 cents, that is a fraction because it's a 0.5 of a dollar. So the same thing in this case, okay? So, well, what is a fraction? Well, a fraction is a number, is a irrational number, that represent part of a whole. Okay, so what is this? Well, the fraction has two different, I would say, entities. Well, the denominator is how many parts are in the whole, right? And the denominator is how many parts from the whole are considered. So in other words, how many parts? If you take away 25 cents from a dollar, so that means that 25 cents have been taken from a dollar, which it reduces to 3/4, right? So 3/4 will be 3/4, right? Because you take away a dollar. You take away from that dollar, you take away 1/4. Only leave with 3/4, which is 3/4 over 3/4 over the 4/4. Okay, if you want to check this out, you divide that 3 divided by 4 is 0.75. Okay, so which is you should get 75 cents after you take away 1/4 from a dollar, right? So that makes sense. Okay, so basically, the denominator is how many parts you have in the whole, and the denominator is how many parts you have in the whole. The numerator is how many parts you are considered from the whole, right? So using this definition, let's see. Okay, so let's say that this circle right here represent a pizza, right? Let's say that you order a pizza, okay, and then the pizza person cut the pizza into different slices, right? And eight different slices, right? 1, 2, 3, 4, 5, 6, 7, 8, right? Now, let's say that you take this pizza home and you start, eating pizza, and you decide to eat, the first slice of pizza, right? So this slice is gone, right? Okay, so this slice is gone. But the pizzas had 8 pieces, right? So technically, you ate 1/8 of a pizza, right? So if you ate if you ate 1/8 of the pizza, how can you represent that as a fraction? Well, it has, because has 8 pieces, right? Then 1 is gone because you ate it, then you have 1/8 of the pizza, right? I'm sorry, you ate 1/8, you ate 1/8 of the pizza, right? So then you eat another slice of the pizza, right? Then this piece is gone, right? Then you have you ate 2/8 of the pizza. Okay? Then let's say that somebody else came in and get another slice. Then you ate 3/8 of the pizza, right? Then somebody else decide come in and get another slice of pizza. This is 4/8 of a pizza, right? Well, 4/8 is equal to technically 1/2. At this point, the whole half of the pizza is gone, right? Because this can be reduced to 1/2. Okay, so anyway, but let me just erase that, because just leave it like that, right? So what I want to show right here is that, see, the numerator is increasing. It's increasing. Well, you eat the pizza, the numerator is increasing. That doesn't make too much sense, right? But the numerator is increasing, but this is the part that is gone that is increasing. Look at this. Okay, this shaded part represents the part that is gone, right? It makes sense because it is increasing in the numerator, but it means that it's reducing the whole size of the pizza. It's reducing it. I mean, the numerator is increasing, and the denominator stay fixed, right? Now let's say that somebody eats another slice. Now you got a 5/8, right? And then somebody else come in and eats another slice. Then you get 6/8. And then somebody else come in and get another slice. Then it's 7/8. So at this point, we ate 7/8 of a pizza, which is 7/8 of a pizza is getting close to the whole pizza, right? Now, somebody else came in and ate this slice. Okay, so right here we have 8. So we ate the well. Let's say that, okay, so the whole pizza has been eaten, right? If the whole pizza has been eaten, then you can write it as 8/8. Well, so what is 8/8 then? That's pretty amazing, because 8/8, if I get the calculator and I divide 8 divided by 8 is equal to 1. So this bit right here represents the whole pizza, which is basically 1. This is amazing, isn't it? So this is how fractions work. You see that the denominator is increasing, but the denominator is the part that we take from the whole. So we're reducing the pizza by increasing the numerator, and increasing the denominator means taking away from the whole. So we're taking away part and taking away part and taking away part. And then the numerator is increasing. Okay, and once the this numerator cannot go beyond this number. Alright, so the numerator has to equal to the denominator. By the time this equal to the denominator, we have a 0 slice overall over here, but we took away 8 pieces, which 8 pieces were in the whole pizza, which is equal to 1. Alright, so let's do some problems. So let's do some problem real quick because I don't have a lot of time. So let's do from this book, the same book, Algebra and Trigonometry. Let's do number 51. Number 51 says 2 over 4 plus 2 over 5. Alright, that's 51. And then let's do 55, which is 5 51 so 51 is 5 over 18 plus 1 over 12. Okay, so let's do this, right? If I have a time, I will do another one. Okay, so let's do these two problems. Now, in this case, we are adding fractions. That's what we do. We add in fractions. Okay? So so let's do these problems. Okay? So first of all, let's see what we have. In this right here, this was 55, okay? Okay, so in this fraction right here, in these two fractions, because there are two fractions, we have 2 over, let's see, did I copy this correct? No, it's supposed to be 3. This is supposed to be 3. Okay, sorry about that. Okay, so 3 over 4 plus 2 over 5. Okay, so I gotta find what is called the least common denominator, LCD, right? LCD stands for least common denominator, right? Okay, so let's do this. So what is the least common denominator? The least common denominator is the least common multiple that I can get by getting by multiplying these two numbers and getting the same number in the bottom. Remember, this is the numerator and this is the denominator. The bottom is the denominator, right? So so what I can do in this case, I can say what number can be common on both. If I multiply this number by a certain number, these two numbers, right? This and this, right? So what number will be the multiple to get these two numbers the same? My goal is to get these numbers the same, right? So what can I do? Okay, so the first step I gotta do is to say, okay, what number is multiple of 5, 4, and 5, right? So obviously, this couple numbers, 40 is too high, 80, right? But let's do another number lower than that because this is the least common denominator, right? So in this case, it's going to be, let's say that, in this case, let's say that 4 times 5. Okay, so but let's do this first. Let's put little parentheses like that, right? And let's put 3 over 4 plus 2 over 5, and then let's put the parentheses around, beside these numbers because we need to multiply, we need to fill this is spaces, right? So we need to fill this spaces. Okay, so how we do this? Well, we say that 20 can be a good number, but why 20? Well, 4 times 5 is equal to 20, right? And 5 times 4 is equal to also 20, right? So in this case, I'm going to have 5 right here and 5 right here, right? And then in this case, I will have to make it this 4, right? And 4. Remember, whatever you do to the top, you have to do it at the bottom. Whatever you do to the bottom, you have to do it at the top, right? Okay, so now let's multiply these numbers, right? And 5 times 3 is 15. And then 5 times 4 is 20. 2 times 4, right? Plus, remember, plus is equal to 8. And then 5 times 4 is 20. Now, I got the two numbers and the denominator, they look the same. Okay? And that is called common denominator. Least common denominator. Okay, so this is the least common denominator, right? Okay, so that's it. Okay, now this is partially done, right? So now let's do, so we found the least common denominator, which is 20, okay? Now, let's add them up. Remember, we added fractions, so we have to add, but when you add this, you only add the numerators. Never and ever try to add this one, the numerators. No, only the numerator is the one get added together. The denominators, they just stay the same. We don't touch those, right? So this is equal to 15 plus 8 is equal to 23 over, over 20, right? Well, what if the teachers tell you to reduce this to the lowest terms, right? If a teacher tells you to reduce to the lowest term, all you have to do is divide 23 by 20, which is going to be 1, right? The remainder is 3, is going to be 3 over 20, right? So therefore, this is the answer, right? This is also the answer. Remember, this is also the answer, but this is not in the standard form. Okay, this right here is, it reduces to the lowest term. And sometimes teachers, they want to say this one. They don't like to say this one because this is called improper fraction. And this is called a fraction already, in the lowest term, which is called a proper fraction. In this case, it's a mixed number, okay? But anyway, let's do the other problem. Let's do the next problem. So That is that one. Let's do this one. Okay, in this case, I have 18, which is a higher number, but it's okay. We can work around with that, right? We can find, we can find the common denominator. Okay, so in this case, I have, I have 18 and 12. I see some common numbers between 18 and 12, which is 6. 12 divided by 2 is 6, and 18 divided by 3 is also 6. Okay, so there is a number that might work with this, and that number might be, some number that can actually, for example, 9 times 2 is 18, right? But I cannot do anything with 9 times 2, okay? Because I mean it's already 18. So what I can do is find a number that, and then 9 times 3 will be 27. But then this doesn't. If I multiply this by 3, it's going to be 36. Wait, but 36 might work. But if I find another number more, if I multiply this by a different number, so 18, right? So 18 times 2, which is 36, right? But let's just do this again. Let's put little bubbles, little parentheses, okay? And then plus 1, and then 12, and then little parentheses over here, okay? So now we have we have this little parentheses that we need to fill them up, okay? So notice that I have 18 times 2, right? And then I will try to, what is 18 times 2 is 36, right? Okay, but then if I do 12 times 2, it only gives me 24. That doesn't go. But what if I said, if I increase this to 3 times 12, 3 times 12 is 36. Okay, so first we check, because I multiply this by 2 is equal to 36. If I try to multiply this by 2 is equal to 24. That doesn't make any sense, right? Now, but what if I do this by 3? Let's try that out. If I multiply 12 by 3. Okay, so I put 3. Whatever you do to the bottom, you have to do to the top, right? Whatever you do to the bottom, you have to do to the top. And then right here, we say that we multiply that by 2, right? By 2, okay? So, okay, so let's do it. So then that will be 10 at the top, right? And then this will be 36. Okay. Now, this times that is plus, right? Well, I put the plus sign and I get 3 over, and the 3 at the top, and the bottom I get 36, right? Now look at this. Now I got a 36, right? On both fractions on the bottom. This is what I'm looking for. I'm looking for the number to be the same in the denominator. That's my goal. So now I just add the numerators, and I get 13 over 36. And this is already in the lowest terms, so therefore this is the answer. I don't have to do anything because the numerator is less than the denominator. So therefore it's a proper fraction, and that's the right answer. Alright, thank you for watching. I hope this helped anybody who was taking, basic mathematics, basic fraction. Thank you for watching.